Alright, in this video we're gonna learn how to factor one that's a little more complicated. So ax squared plus bx plus c. So this is one where you have a number in front of the x squared, and that number is not just a 1. We do actually know how to do a couple, like we did see something like this. 2x squared plus, I don't know, say 8x plus 6. So you should know how to factor something like this from the last video, and that would be the way you deal with the number in front of the x squared. In this case, is it's a common factor to all the terms, so you can common factor. So it'd be 4x plus 3, and then inside the bracket now you have just a sort of a simpler trinomial where it's just 1. So then you could just do 2 binomials x product of 3 sum of 4, so that'd be 3 and 1. So if it's a common factor, it's easy to deal with the number in front of the x squared. But what if it's not? What if this 2, like what if you had something like I don't know, plus, let's say 7x plus 3. So in this case, the 2 is not divisible by, or each term is not divisible by 2, so you don't have a common factor of 2, so you can't do this. But this still might be a product of 2 binomials. And let's see, how we might get something like this. So let's again remember that factoring is the opposite of expanding. Let's say you had a bracket or 2 binomials like this, and you were asked to expand. Well, 2x times x and 2x times 3. So you have 2x times x is 2x squared. 2x times 3 is 6x. 1 plus x is, or sorry, 1 times x, and then 1 times 3. And then just add the like terms. So it'd be 7x plus 3. So so we see actually it's that question that I mentioned earlier, right? Same thing. So 2x squared plus 7x plus 3, but we want to be able to go this way. So we want to be able to factor I don't need a bracket. We want to be able to factor 2x squared plus 7x plus 3. Well, we know that it factors to this, but we want to be able to figure out how did we get these numbers. So we know it's going to be 2 binomials. The first 2 terms, here and here, must multiply to give us this, 2x squared. So the coefficient, well, we know it's going to be x squared, or x and x, but there's going to be something in front of it. And we know that the coefficients, the numbers in front of the x, are going to multiply to give you 2. So what I'm going to do is I'm going to write down all the numbers that multiply to give me 2. Well, in this case it's only 2 and 1. So that's good. There's just 2 options in this case. Actually, in this case we know it's got to be 2 and 1. So that's nice. 2 and I won't write the 1. If you had more options, it'd be a little more complicated. And then the last term, 3, we know that the product of these 2 things is going to give us 3. So I'm going to write those down here. 3 and 1. Now, how do I decide, is the 3 here or here? Is the 1 here or here? Well, this is where I look at this number. Where did the 7 come from? The 7 came from over here, adding the 6 and the 1. And then where did the 6 and the 1 come from? Well, the 6 came from 2 times 3, and the 1 came from 1 times 1. So 2 times 3, that was one of these numbers times one of these numbers, and then the 1 came from the other number here times the other number here. So which numbers do I have to multiply such that when I add them, I'll get 7? So if I do 2 times 3 and 1 times 1. So 2 times 3 is 6, 1 times 1 is 1, 6 plus 1 is 7, which is what I wanted. So that means I need to multiply the 2 by the 3. 2 times 3, if I want to multiply 2 by the 3, where should I put the 3 in this bracket? Or which bracket should I put the 3 in? If I put the 3 here, I won't multiply the 2 and the 3, so I need to put it in the opposite bracket to the 2. And then similarly the 1 then must go there. So it's a much more complicated process. Not much more, but it's more complicated than the other trinomials. Let's try another one. So let's say something 3x squared, so we're going to factor plus 17x plus 10. So we know two binomials. Now the first term, x, x, and then what goes in front of the x? Well, it needs to multiply to 3x squared. So what multiplies to give you 3? Again, we're lucky. Our only options are 3 and 1. So I'll put the 3 here, and then this one will be 1. And you could put the 1 here, and then put the 3 here. That's fine too. Now, the last terms must multiply to 10. So what multiplies to give you 10? Well, there's two options, right? 5 and 2 and 10 and 1. Could be either of these. But we need to make sure that when we multiply one of these with one of these, and then one of these with the other one, we get 17. So let's try 3 times 5, that gives us 15, and 1 times 2, that gives us 2. 15 plus 2 is 17. Okay, got lucky. That was it. First guess. So 5 and 2. I want to multiply the 3 by the 5, so I'll put them in opposite brackets. And I want to multiply the 1 by the 2, so I'll put them in opposite brackets. And that should be it. If you expand, you should get back this. I'll let you do that. So just try expanding this to get back that one. Let's try one where we don't guess it so well to begin with. Let's say 5x squared. Let's throw in a minus. Let's just do minus x plus 6. Sorry, not plus 6. Minus 6. So again, two brackets. Two binomials. And then our first term needs to multiply to 5. Well, what multiplies to 5? Again, we're lucky, just 5 and 1. So we'll go 5x and 1x, which is just x. And then what multiplies to give us 6, or negative 6? There's actually a lot of numbers. Not a lot, but what multiplies. So let's say 1 has to be negative, so negative 3 and 2. Or it could be 3 and negative 2. Or it could be 6 and negative 1. Or it could be negative 6 and 1. So now, okay, so let's try 5 times negative 3 and 1 times 2. 5 times negative 3 is negative 15, and 1 times 2 is 2. Negative 15 plus 2 doesn't give me negative 1. So it doesn't, that combination doesn't work. But I could also do 5 times 2 and 1 times negative 3. Well, what's 5 times 2? 10. 1 times negative 3, negative 3. If I add those, I get 7, not negative 1. So this pair doesn't work. It's not that pair. Now you're going to try this pair. 5 times 3, 15. 1 times negative 2, negative 2. Adds to 13. So that doesn't work. But then try the diagonal. And if you try that one, this pair is not going to work. So you have to move to the next pair. 5 times 6, 30. 1 times negative 1, negative 1. Doesn't add to negative 1. Try the diagonal. 5 times negative 1 is negative 5. 1 times 6 is 6. If I add those together, I get positive 1. Almost. I want a negative 1. So this pair doesn't work. But, So now we're on to the last pair. Hopefully this pair works. 5 times negative 6, negative 30. 1 times 1, 1. If you add those, nope, doesn't give me negative 1. But now let's try the diagonal. 5 times 1 is 5. 1 times negative 6 is negative 6. If I add those, I get negative 1. So this is the pair that works. So let's make sure we put them in the right brackets. Remember, I wanted to multiply 5 and 1. So I need 5 and 1 in opposite brackets. And I need the 1 and the negative 6 in opposite brackets. So this is sort of the correct order. So we had to go through three pairs before we got to the pair that worked. And you might be looking at this and saying, oh, do I have to do that every time? Like, there could be tons of pairs. And you're right, there could be tons of pairs. One thing you're going to notice when you get better at this, you're going to be able to eliminate certain pairs very quickly. You have to have a good number sense. You have to be able to multiply quickly and add negative numbers quickly just to see the sums. Otherwise, it's going to take forever. It's true, but you know the best way to get better at this is to just practice them. So we'll just do one more. Let's say we go 7x squared plus 11x plus 4. So, do binomials. What multiplies to give you 7? So again, just 7 and the 1. So we got lucky again. 7x and x. And then what multiplies to give you 4? Well, 2, 2, 4, 1. And then since it's positive and this one's positive, I don't have to worry about negative numbers. So we'll try multiplying. So 7 times 2, 14. 1 times 2, 2. If I add those, I don't get 11. So it doesn't work. You could try the diagonal, but notice 2 and 2, it's the same. So this pair doesn't work. How about this? 7 times 4, 28. 1 times 1, 1 doesn't add. So hopefully this diagonal will work. 7 times 1 is 7. 1 times 4 is 4. If I add those together, I get 11. So that worked. So it's 7 times 1. So 7, I'll put the 1 in the opposite bracket, and 1 times 4. Okay, so just practice makes perfect. So just keep doing these.